Welcome back. In the previous video, we learned how to write our first C++ program, understood its structure, explored variables, data types, and even took user input. Now it's time to make our programs think and act intelligently. Up till now, our programs just executed one line after another, but problems often need decisions and repetition. For example, what if you want to check whether a number is positive or negative? Or print a message 5 times automatically. That's exactly what we will learn in this video. We will explore concepts that make every program dynamic and logical. Let's begin by learning how computers make decisions using the if statement. Let's begin with a simple problem to understand how computers make decisions. We want to write a program that reads a number from the user and prints non-negative if the number is 0 or positive. It prints negative if the number is less than 0. In short, the program should decide what to print depending on the number sign. So far, our programs executed one line after another. But this time we want our code to choose between two possible actions. That's where the if-else structure comes in. Now let us understand how this program works. The first line, hash include IOStream, provides the input and output objects cin and cout. Next, we have a multi-line comment. It's just a description for the human reader. The compiler ignores everything inside these comment markers. Good programs always include comments to explain the purpose of the code. Next, we have using namespace line that tells the compiler that we are using the standard namespace inside main function. We declare an integer variable called number to store the input value that the user will enter. The following line displays a message on the screen asking the user for a number. The insertion operator sends text to the standard output, your terminal or console. Next, we read the input. The cin object reads the input from the keyboard. The extraction operator sends whatever user types into the variable number. Now comes the most important part, decision making. The if statement checks a condition, here whether the number is greater than or equal to 0. If that condition is true, the block of code inside the curly braces is executed. So if the number is 0 or positive, it prints non-negative. Notice the use of braces. They group multiple statements together as one logical block. Even though we have only one line here, using braces is good habit, especially for beginners. The else part handles all other cases. That is, when the if condition is false. So if the number is less than 0, this part runs and prints negative number. The return statement tells the operating system that the program ran successfully. Let's compile and test it with some inputs. So our program name is if-else, and I am giving the name to the executable as if-else. The program has compiled successfully. Now the program is expecting some number to be given as input. So I'm typing 10. It's telling non-negative. Let's run it again. And now I'm giving -5. It tells negative. Let us try with value 0. And that is also non-negative. Let us look at another simple but interesting problem. We want to write a program that reads a positive integer from the user and prints its factorial. For example, if the input is 5, the program should display 5 factorial is equal to 120 because 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 is equal to 120. If the input is 3, the output should be 3 factorial, which is 6. But if the user enters a negative number, that doesn't make sense for factorial. So our program should detect that and show an error message. This problem will help us understand two important ideas in programming. Conditional statement to check if input is valid, and second, loops to repeat a multiplication process. Let us look at the program that achieves this goal. As we are familiar with hash include, namespace, and main, let us directly jump into if statement. This if statement checks whether the user has entered a negative number. If so, print an error message, incorrect input, require positive integer. and exit the program immediately using return 1. Now comes the main part, calculating the factorial. We start by declaring a variable prod and initialize it to 1. This variable will store the product as we multiply numbers one by one. The for loop here repeats the multiplication from I equal to 2 to I equal to num. Let's break it down. So the first part is initialization, which is int I equal to 2, which starts counting from 2. The second part is the condition, and it tests for the continuity, which is loop continues while I is less than or equal to num. The third part is update. After each iteration, I increases by 1. And next is the body that multiplies prod by I on each pass. So the user enters 5. Here is what happens step by step. Initially, prod is equal to 1, multiplied by 2, so prod becomes 2, multiply by 3, then prod becomes 6, and then multiply by 4 and 5, prod becomes 24 and 120. So when the loop finishes, prod holds the factorial value. The next line prints the final result in a readable format. The expression written in cout builds the entire statement in readable format. For example, if num is 5, it prints 5 is equal to 120. Let us see this program in action. So I'm compiling this, and our program is in fact.cpp, and I'm giving the name of executable as fact. So when I run it, it's asking for some number. I'm giving 5, and it prints 5 factorial. Let us try this with a negative number. And it says incorrect input, require positive integer. So next, consider another simple but real world problem. We want to write a program that keeps reading numbers from the user one after the another and adds them all up. But there's a twist. We don't know in advance how many numbers the users will enter. So the program should keep accepting numbers until the user signals that they are done. After that, it should display the total sum of all the numbers entered. This is a great example to understand when and why we use a while loop. Because unlike the for loop, here we can't predict how many times we will have to repeat the input process. Here is the program that achieves this goal. We declare two integer variables, num to store the current number entered by the user and sum initialized to 0 to accumulate the total of all numbers entered. This line displays an instruction to the user. It tells them to keep typing numbers and to press Ctrl D or Ctrl Z on Windows when they want to stop. That keyboard signal represents the end of input, also known as end of file or EOF. Now, this is the key part of the program. The while loop continues as long as input succeeds, that is, as long as the user keeps entering valid numbers. Here is what happens by step. The expression C in num tries to read a number. If successful, it returns true and the loop body executes. Inside the loop, we add the number to sum using sum plus equal to num. The loop then repeats, waiting for the next number. When the user presses Ctrl D or Ctrl Z on Windows, input fails and C in num becomes false. The loop ends automatically. Once the loop finishes, the program prints the total sum of all numbers entered. The cout statement combines text and variables using the insertion operator. This line signals, which is return 0, the successful completion of the program. Let's see how it works in practice. So I'm compiling this program, which is stored in loop.cpp, and the executable is loop. So it's now asking for the inputs to be given. So I'm giving 1, 2, 3, 4, 5. And if I don't wish to continue, I will press Ctrl D, and it's saying sum of numbers is 0. Let's try another run. Now, if I don't want to give any input at all, let me press Ctrl D and see what happens. So since I did not give any input, it's saying the sum of numbers is 0, which is what is expected. So in this lesson, we explored three of the most important building blocks in C++ programming: conditions, loops, and control flow. Let's quickly recap what we have learned. First, we learned how to make decisions using the if-else structure. The if statement allows a program to check a condition. If it's true, one part of the code runs, otherwise the else part takes over. Next, we looked at the for loop, which repeats a set of instructions a fixed number of times. It's perfect when we know exactly how many times we need to repeat something. Then we learned about the while loop, which repeats as long as a condition remains true. Unlike the for loop, it's used when we don't know in advance how many times we will be repeating something.